Hey everyone, thank you for joining me today. Hope you're doing well. So today we're going to discuss differentiation using the first principle. I'm going to guide you through the steps of differentiation using the first principle. Now, before we talk about dy dx, it's important to talk about change in y over change in x. Okay, that's because that's where the idea of differentiation comes from. Now, change in y over change in x. Okay, now let's first thing I'm going to go to a graph. Okay. Now I'm going to use Desmos graphing calculator because I think it's a good one. So assuming we had, let's say, an equation y equals, say, x plus 5, all right? Y equals, or let me something, y equals x plus 3, okay? And I say find the gradient of this equation, find the gradient of this line. So just easy, so we can pick 2 points, let's say here, and say here, okay? And then let's match. So we have our x here, or this could be our x1, this will be our x2. Match it here, so this will be our y1, and this will be our y2. Okay, so gradient will be that's change in y over change in x. Okay, which will be y2 minus y1 over x2 minus x1, right? So this will be it should be 5 and it should be 7, right? So we have 7 minus 5 over have 4 minus 2, which is 2 over 2, 1. Okay, our gradient is 1. All right, which is fairly simple, finding the gradient of a straight line. But what if we have, let's say we have another equation and say we have, use this, let's say we have x. If you're going to put square, so y equals x, press shift and 6, x squared plus 3, okay? X plus 3, x squared plus 3. Now, we have a problem because here we had what we call a uniform gradient. It means the gradient was the same throughout. But for a curved line, the gradient is changing all the time. All right, the gradient is changing all the time. So the gradient here is different from the gradient here. The gradient here is also different from the gradient here. Okay, so how do we find the gradient at this point? So let's say this point here, how do we find the gradient? The best we can do is to draw a line that just touches. So let me see if I can do that here. A line that, let me draw a line here. Let me edit the line a bit. Okay, something like this, a line that's just, yeah. So we're gonna draw a line that just touches this point, and this is gonna be our tangent line. There we can find our x1 and x2. Okay, which is fine, but sometimes it's not that accurate, okay, because trying to do this matching, it's gonna be a bit inaccurate. So this is where differentiation comes in. Now we have x1, okay, let's say we have x1 and say x2, so this point. Okay, now in some books you see something like this. We have x and then we have x plus delta x. It's still the same thing, okay? Assume we have 1 here and say we have 2 here, delta x will be 2 minus 1. That's x2 minus x1. So it's still the same thing, or you would see x here and x plus h. Same thing, all right? So x2 is just x plus h. Same thing, you have y. Okay, we have y can have y1 and say y2, or some people will write y and then y plus delta y. Same thing. Okay, so what the idea is that, okay, the idea is that when you have a gradient, okay, delta y over delta x, it will be y2 minus y1 over x2 minus x1, or some people write it as y1 plus, just put y plus delta y minus y1 or minus y. Okay, and we have x plus delta x minus x. Okay, so let's go back. let's go back here. So the idea of using differentiation is to find the rate of change, to find a gradient at a particular point. Okay, that's just what it is, to find the gradient at a particular point, especially on a curved graph. All right, so I put this here. Now, delta y over delta x. Now remember, y is a function of x, meaning the value of y depends on the value of x. So let's say we have an equation 2x plus 3. So if x is 1, y will be 5. If x is 2, y will be x is 2, y will be 7. All right, so the value of y depends on the value of x. All right, so we have delta y over delta x will be f of x plus delta x. This is y2, this stands for y2, minus f of x, which is actually y1 or y, over delta x, which is x2 minus x1, or some people will write it as x plus delta x minus x. Okay, so I'm going to write that again. Delta y over delta x equals f of x plus delta x minus f of x over delta x. Okay, so let's try an equation. So let's try 2x squared plus 5. And we're asked to differentiate with the first principle. So the first thing you do is just to bring out your equations first. Okay, delta y over delta x. That will be f of x plus delta x minus f of x over delta x. So how do we go about it? We're going to replace x with everything we have here. Okay, we're going to replace x with this. So we have something like this. So we have 2, okay, 2 x plus delta x squared plus 5. That's the first one. That's f of x plus delta x minus f of x. That will be 2x squared plus 5 over delta x. Okay, so let me clear everything. Let me erase this part first. Okay, so let's try to open the bracket. Let me use my normal small handwriting. Now we have x plus delta x all squared. Now to be fast about this, so we don't have to open brackets. Remember, I also talked about this in a previous video. A plus b all squared will give us a squared plus 2ab plus b squared. So meaning x plus delta x all squared will give us x squared plus 2x delta x plus delta x all squared, right? So we have it here. So we can have 2, okay, we have this x squared plus 2x delta x, okay, plus delta x all squared. And then we have plus 5 here. Okay, wait. Okay, then minus, okay, 2x squared plus 5. So let's do with the numerator first. Now, when we open this bracket, everything is going to be negative, right? So let's, this one, 2, we have 2x squared plus 2 times 2, that's 4, x delta x plus, okay, delta x, 2 delta x all squared plus 5 minus 2x squared plus 5. Now from the onset we can see plus 5 minus 5. Sorry, remove this. When you open the bracket it turns to negative. It's now minus 5. So we have plus 5 minus 5, and we can see that whenever we're differentiating, the constant usually becomes 0. All right, so we have plus 5 minus 5 goes away. 2x squared minus 2x squared goes away. So we're left with 4x delta x plus 2 delta x all squared over delta x, remember? Okay, and then what's common here? Delta x, open the bracket. Okay, we have 4x plus 2 delta x. Okay, we don't have to put the bracket here, so I can just remove this. Okay, 2 delta x over delta x, and then delta x divided by delta x. We're left with 4x plus 2 delta x. Now, this is just delta y over delta x. Now, dy dx is when you have the limit as delta x gets to 0. Now, once delta x becomes 0, this disappears, and we're left with 4x. So dy dx will be 4x. Okay, so let me just put this here. So assuming we have y equals 2x squared plus 5, delta y over delta x will be 4x plus 2 delta x, and then dy dx, which is equal to delta y over delta x, limit as delta x gets to 0 will be 4x. All right, so that's just it. Okay, I hope you understand this, and I'm actually going to do an exercise first so that we can do this more. So I got some materials from here. Wait, let me see. Check. Yeah, let's try this one. Y equals x squared plus 2x plus 1. So I'm going to go back. Okay, I'm going to go back and put it. Y equals x squared plus 2x plus 1. Let's say y equals x squared plus 2x plus 1. And then we're asked to differentiate with the first principle. Step 1, okay, put our equation. So delta y over delta x will be f of x plus delta x minus f of x over delta x. So what's our equation here? X squared plus. So we just put x plus delta x for x here. So we have in the first part, so it's going to take some space. So we have x plus delta x squared. Okay, we're replacing x with delta x plus delta x plus 2. What are we going to have here? X plus delta x plus 1. Okay, first part, f of x plus delta x part minus f of x, we just have x squared plus 2x plus 1. Okay, now what do we do here? We have x plus delta x all squared. Sorry, delta x. So like we said, a plus b all squared will be a squared plus 2ab plus b squared, right? So same thing here. We have x squared plus 2x delta x, okay, plus delta x all squared. Let's continue. 2 times x, we have 2x plus 2 delta x plus 1 minus, okay, let's quickly open this. Okay, let's open the bracket quickly. So all positive signs will change to negative, right? Because there's a negative sign before the bracket. So we have minus x squared plus 2x minus 2x, okay, minus 2x, sorry, minus 1. Okay, so we can start to cancel x squared minus x squared. Okay, what else? We have 2x here, 2x minus 2x, 1 minus 1. What are we left with? we're left with 2x. Everything is over delta x, right? Just remembering that, just in case. Okay, 2x delta x plus delta x all squared, okay, plus 2 delta x over delta x. So delta x we can factorize using delta x. So we have delta x bracket 2x plus delta x plus 2 over delta x. So delta x goes, we're left with. So changing y over changing x will be 2x plus delta x plus 2. Now remember, dy dx will become delta y over delta x limit as delta x approaches 0. So when delta x is 0, we're left with 2x plus 2. And if you want to confirm if it's correct, you can use the quick method as a way to confirm that you're correct. So we have x squared plus 2x plus 1. Okay, we bring this here. Remember, all constants become 0. Okay, that's the first step. And then we multiply the coefficient, which is 1 here, by the power of x. So we have 1 times 2. Subtract the original power by 1. 2 minus 1 will be x to the power 1 plus, same thing here, x to the power 1, right? So we have 2 times 1, x to the power 1 minus 1, 0. So what we have here will be 2x. And anything raised to power 0 is 1. So 2 times 1 is 2. So 2x plus 2. And let's just confirm. Okay, let's confirm from here. I know it's long, but it's good to know. So let's see if so let's click on the answers just for A, okay? Just A. So we have 2x plus 2, which is correct, as you can see. Okay, we're not doing the others yet, but if you want us to do that, we can do that. We can do everything, try to understand differentiations. The best way to do math is just to keep solving, solve problems, test yourself, challenge yourself. Okay, hopefully we'll be able to do all this. Okay, maybe I'll make videos explaining each and every one. So let's see. At least we got our answers correct. And then I also have this one, this article I found. Okay, here. I think we can do one. Let's just do the simple ones first. Okay, the one without numbers. Okay, let me see. Let's go to level. Let's start with level 1 first. Okay, or supposing we have something like this, without numbers. Let's say x to the power 4. Okay, let's say y equals x to the power 4. How do we differentiate this? Using the first principle. So we'll bring out our equation again. So we have dy dx equals f of x plus delta x minus f of x over delta x. So here our y is x, so we have x plus delta x to the power 4 minus x to the power 4 over delta x. Now we have to the power 4. So this is where the Pascal's triangle will be very helpful. So instead of having to multiply and multiply, you have something like this. We have 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 6, 4, 1. How did I get this? Oh, wait, it should be 1, 4, 6, 1. Sorry. 4, just 1, 6. Yeah, so we have 3 values here, 4 values here, 5 values here, not 6, 6, 1, 6. Okay, so what we have is x to the power 4 plus 4x cubed delta x plus 6x squared delta x all squared plus 4x delta x cubed plus delta x to the power 4. So the Pascal's triangle helps you in opening brackets. As you can see, the trick here is that the value of, the power of the first value, which is x here, starts from 4 and decreases 4, 3, 2, 1, and then disappears. And the value of the second value, the power of the second value starts from here. Okay, you can see x squared, cubed, and 4. Okay, so this is what we have. Minus, okay, all this minus x to the power 4. Okay, let's just put minus x to the power 4 here. So we're going to cancel. We're left with, okay, so we're left with, sorry, my pen is acting. All right, so let me erase this part. So we're left with, okay, 4x cubed delta x plus 6x squared delta x squared plus 4x delta x cubed plus delta x to the power 4, everything over delta x. So let's bring out delta x from, okay, let's bring out delta x. So we have, when you factorize delta x, have 4x to the power 3, okay, plus 6x squared delta x plus 4x delta x to the power 2, or x squared, plus delta x cubed over delta x. Okay, so this can cancel. So we're left with, sorry, we just keep moving, don't have space. Okay, we're left with 4x cubed plus 6x squared delta x plus 4x delta x squared plus delta x cubed. Okay, so this will just be changing y over changing x. Now dy dx will be this limit as changing x gets to 0. So anything that has delta x here automatically disappears. So we have this one disappears, this disappears, and we're left with 4x to the power 3. Okay, so let's put our value and see. For shift 6, I'm sorry, for x first, shift 6, 3, and then we check, and it's correct. Okay, so I think this is where I'll stop for now, and hopefully if I made any mistakes, please let me know. We're just going to be practicing from now on. If it helps, let me know. If there's anything I can do to help, if you want to learn more with me personally, you can also write in the comments, and we can also organize that. So I'm just here to learn and understand math. Thank you and have a nice day. Bye-bye.